to identify the characteristics of different classes of chemical reactions. So this means to put them into sections or put them into categories, and then we're going to talk about what characteristics are common in each of the different categories. Vocabulary: synthesis reaction, combustion reaction, decomposition reaction. You notice here D means to undo or take apart, or minus. So we're going to undo a composition to take it apart. Single replacement reaction, double replacement reaction, precipitate. Excuse me. How long do you think it would take you to find your favorite author's new novel in an unorganized bookstore? Because there are so many books in bookstores, it could take you a very long time. Bookstores, such as the store shown in Figure 10-5, supermarkets, and music stores are among the many places where things are classified and organized. Chemists classify chemical reactions in order to organize the many reactions that occur daily in living things, laboratories, and industry. Knowing the categories of chemical reactions can help you remember and understand them. It also can help you recognize patterns and predict the products of many chemical reactions. Chemists classify reaction in different ways. One way is to distinguish among 5 types of chemical reactions: synthesis, combustion, decomposition, single replacement, and double replacement reactions. Some reactions fit equally well into more than one of these classes. Okay, so we're going to classify them, and here are the different types. They've just been listed for us, and I can see that synthesis is the first subheading, and so I'm thinking that each section is going to be a different kind of classification. Here's a picture of books in a library, and if they weren't classified, we'd never find a book, right? Okay, synthesis reactions. In the previous section, you read about the reaction that occurs between iron and chlorine gas to produce iron 3 chloride. In this reaction, 2 elements, A and B, combine to produce one new compound, AB. Iron and 3 iron solid plus 3 chlorine 2 gas react to produce 2 iron chloride 3 solid. Okay, the reaction between iron and chlorine gas is an example of a synthesis reaction, a chemical reaction in which 2 or more substances react to produce a single product. 2 or more substances react to produce one single product. When 2 elements react, the reaction is always a synthesis reaction. Another example of a synthesis reaction is shown below. In this reaction, sodium and chlorine react to produce sodium chloride. Sodium and chlorine react to produce sodium chloride. Here's the sodium, here's the chlorine, which comes 2 together, and it reacts to produce sodium chloride. Just as 2 elements can combine, 2 compounds can also combine to form one compound. Okay, so these are elements, but we're also going to see compounds combining. Okay, this is an element, sodium, this is an element, iron, but now we're going to have a compound. For example, the reaction between calcium oxide and water to form calcium hydroxide. This is a synthesis reaction. Calcium oxide and water react to produce calcium hydroxide. Another type of synthesis reaction may involve a reaction between a compound and an element, as happens when sulfur dioxide gas reacts with oxygen gas to form sulfur trioxide. Okay, these are all synthesis reactions. Synthesis means to bring something together. If you're going to synthesize an argument or synthesize your thoughts in a paper, you take all of your thoughts and you bring them together, and this is a synthesis reaction. Combustion. The word bust in the middle of this makes me think that something's going to come apart, but let's see if that's true. The synthesis reaction between sulfur dioxide and oxygen can be classified also as a combustion reaction. In a combustion reaction, oxygen combines with a substance and releases energy in the form of heat and light. Aha, there's that busting I'm thinking of. Heat and light are produced. Oxygen can combine in this way with many different substances, making combustion reactions common. A combustion reaction, such as the one shown in figure 10.6 over here, occurs between hydrogen and oxygen when hydrogen is heated. Water is formed during the reaction and a large amount of energy is released. The tragedy of the Challenger space mission was the result of a combustion reaction between oxygen and hydrogen. This was a space shuttle that blew up right after the launch. Remember watching that on TV when I was an elementary student. Another important combustion reaction occurs when coal is burned to produce energy. Coal is called a fossil fuel because it contains the remains of plants that lived long ago, right? A fossil is something in the ground that used to be alive, and so these are plants. So a fossil fuel is fuel that comes from these plants that have now been fossilized. It is composed primarily of the element carbon. Coal-burning power plants generate electric power in many parts of the United States. The primary reaction that occurs in these plants is between carbon and oxygen. So we have an atom and an atom, or an element and an element, react to produce compound. Note that the combustion reaction just mentioned are also synthesis reactions. However, not all combustion reactions are synthesis reactions. For example, the reaction involving methane gas, CH4, and oxygen, methane gas and oxygen, illustrates a combustion reaction in which one substance replaces another in the formation of products. So here, oxygen replaces the carbon. So oxygen goes with carbon and oxygen goes with hydrogen and produces CO2 and H2 in water, carbon dioxide and water. Methane, which belongs to a group of substances called hydrocarbons, is the major component of natural gas. All hydrocarbons contain carbon and hydrogen and burn in oxygen to yield the same products that methane does, carbon dioxide and water. For example, most cars and trucks are powered by gasoline, which contains hydrocarbons. In engines, gasoline is combined with oxygen, producing carbon dioxide, water, and energy that powers the vehicles. You will learn more about hydrocarbons in chapter 22. Okay, so a combustion reaction is when oxygen combines with a substance and releases energy in the form of heat and light. Okay, so it might be a synthesis reaction like this one, or it could be a replacement reaction like this one, which we haven't learned about yet, but we're going to, I think, in a moment. Okay, here's some practice problems for you to look at on your own. Let's look at this figure since it's here at the top. The decomposition of sodium azide, which produces a gas, is key to inflatable airbags, that are here in the car. Decomposition reactions. Something is going to come apart here in this reaction. Some chemical reactions are essentially the opposite of synthesis reactions. Okay, synthesis means bring together. Decompose or decomposition means to take it apart. These reactions are classified as decomposition reactions. A decomposition reaction is one in which a single compound breaks down into two or more elements or new compounds. In generic terms, in other words, as an example, decomposition reactions look like this. AB reacts to produce A plus B. Okay, so see how it's coming apart. Decomposition reactions often require an energy source, such as heat or light or electricity, to occur. Okay, so this is maybe different from a combustion reaction, which produces, right? These release energy in heat and light, and this decomposition requires or needs energy to occur. For example, ammonium nitrate breaks down into dinitrogen monoxide and water when the reactant is heated to a high temperature. Okay. This one is ammonium nitrate, and this is dinitrogen monoxide and water. You can see, so here we have one compound that yields two different compounds. You can see that this decomposition reaction involves one reactant breaking down into more than one product. The outcome of another decomposition reaction is shown in figure 10-7. Automobile safety airbags inflate rapidly as sodium azide pellets decompose. A device that can provide an electrical signal to start the reaction is packaged inside airbags along with the sodium azide pellets. When the device is activated, sodium azide decomposes, producing nitrogen gas that quickly inflates the safety bag. So, the sodium, this must be the sodium azide, and it produces nitrogen gas and sodium. Okay, so here you start with a compound. It reacts to produce, it needs some kind of energy source, like heat, is that, or electricity, and then it can produce either other compounds or other elements. Okay.